So I welcome you all in a new video in which we are going to discuss the chemistry sample paper, and this is kind of unit test or the periodic test you say. Alright, so I think that in this first two chapters of the chemistry are included. Now let's just start. In the first question, we are asked that how many molecules are present in 1 gram of oxygen? I mean hydrogen. So you must know that hydrogen, by hydrogen they mean to say H2. With hydrogen, they mean to say this is H2 because we know that hydrogen exists in the form of H2 only. Alright, so we have to find how many molecules are present in 1 gram of hydrogen. So this is basically 2 grams of hydrogen. 2 grams of hydrogen, that means it is 1 mole. And by 1 mole, it means it contains molecules which are equal to the Avogadro's number. I hope everyone knows this. Now here comes, we are given 1 gram. So rest of all is the same. So it will be Avogadro's number divided by 2, and which will be equal to the C part, that is 3.0125 multiplied by 10 to the power 23, which is the C part. So this is the first question. Moving towards the next question. In the next question, we are asked the number of oxygen atoms present in 10.6 grams of Na2CO3. We have to find the number of oxygen atoms. So to solve this kind of question, firstly we must know what is the molecular mass of the given compound, that is Na2CO3. So let's just find it out. 2 multiplied by 23 plus 12 plus 16, and which is multiplied by 3. Now this whole will be equal to 46 plus 12 plus 48. Okay, and this, if we will sum all this, I guess it will be equal to 106. Let's just take 46, 48. 48 and 12 becomes 60, and 60 and 46 becomes 106. Yes, this will be equal to 106 grams. We have to find the number of moles of the given compound. The number of moles here will be given mass upon molar mass. The given mass is 10.6 divided by 106, which will be equals to 0.1. So it will be 0.1 mole. Now here comes the oxygen atoms. In 1 mole there were 3 O atoms, or we can say 3 mole of O atoms. 3 mole of oxygen atoms in 1 mole of the given compound, that is Na2CO3. Okay, but here in the given it is 0.1 mole. 0.1 mole of oxygen atom will give us 0.1 mole of Na2CO3. Na2CO3 will give us 0.3 moles of oxygen atoms. And what is 0.3 mole of oxygen atom equal to? Simply multiply it by 0.3 multiplied by 6.022 multiplied by 10 to the power 23. which will be equal to 3 multiplied by 6.022, 18.022 multiplied by 10 to the power 22, which will be equal to 1.8 1.8022 multiplied by 10 to the power 23. That is the C. Yeah, C option is the correct. Let's just take it. C option is the correct. I hope you understood this question. Let me just clear this whole thing. Okay, now here comes the third question. And what is the third question? The number of moles of BaCO3 which contain 1.5 moles of oxygen atom are. Okay, see, in 1 mole of BaCO3, 1 mole of BaCO3 contains 3 moles of oxygen atoms. 3 moles of oxygen atoms. So we have to find how many moles of BaCO3 will contain 1.5 mole of oxygen atoms. Yes. So we will divide it by 2 here, and here also we will divide by 2. It will be 1.5, and this will be 0.5. So the answer is 0.5 mole of BaCO3. BaCO3, which is the A part. Now the fourth question. What does it say? Under the same condition, two gases will have same number of molecules. They must be noble gases, have equal volumes or have equal number of atoms, or have 22.4 liter volume each. We have to find same number of molecules. The same number of molecules will only be when there will be same number of moles. And moles for moles, I guess 22.4 liter volume each is the right condition here. Okay, next question. Which has the maximum number of atoms? Okay, see, here we are doing the fifth question. In the A part of fifth question, we will be having 2 moles. Then in the second part, we'll be having 1 mole. And in the C part, we'll be having 0 point something. Let it be 0.1. This is 0.1. And in the fourth one, there will be 1. So the maximum number of atoms will be in A part. Next, as we move away from nucleus, the energy of the orbit decreases or increases or remains unchanged. None of these. Okay, this is a conceptual question. We are moving away from the nucleus and we are asked about the energy of the orbit. Does it decrease, increase, remains unchanged, or none of these? देखो यार, this is a nucleus. This is the first orbit, second orbit, third orbit. Okay, the energy of the first orbit is the highest, but as we move away from the nucleus, the energy of the orbit decreases. The energy of the orbit decreases. So the correct answer for this will be A part, that is decreases. Next question, that is the seventh one. The radius of the atom is of the order of 10 raised to power minus 10, 10 raised to power minus 10 centimeters or meters. See, it was 10 raised to power minus 10 meters. Multiplying it by 100 will give us 10 raised to power 8 minus 8 meters, centimeters. Yeah. So D option will be correct here. A part is wrong. Second is the splitting of the spectral lines under the influence of magnetic field. is called as Stark effect, photoelectric effect, Zeeman effect, or polarization effect. So magnetic, I guess it is Zeeman effect. Next, if the radius of the first Bohr's orbit is a naught, then the radius of the third Bohr orbit will be. You must all know that Bohr orbit R is directly proportional to the n square, if I am not wrong. So here the answer will be n times of a naught. Next, the relationship between the energy A and the radiation with a wavelength 8,000 angstrom and the energy of the radiation of the wavelength 16,000 angstrom. All right. Uh, Ninth question we have done. So it is 10th question now. We will write here even. I guess you all know that energy is equal to hc upon lambda, where h is the Planck's constant and lambda is the de Broglie wavelength. We are given the wavelength here. So E1 is basically hc. Don't no need to put the values of h and c here. Lambda. The lambda is 8,000 angstrom. I'll simply write here 8k, and E2 is equals to hc upon 16k angstrom. Dividing both sides, E1 upon E2. We will divide both here, E1 upon E2. This is the way. So we will get here 1 by 8 and 1 by 16. So what will happen? This 16 will go up. Yeah, the 16 will go up and it will be 2 upon 1. That is E1 equals to twice of E2, which is the option B. Option B is the correct answer here. So we have completed all our MCQs. Now we will move forward to the next part of the question paper. Now first let me just clear this all stuff. The section B. Question number 11. What is asked in the question number 11? Calculate the number of electrons in 20 grams of NaOH. So simple it is. See, firstly we need to know the molecular mass of NaOH. Then we will find the moles. Okay, so NaOH. It will be 23 plus 16 plus 1, which will be equal to 23, and 16 will give it 49, 39 plus 1, 40. 40 grams is the molecular mass of NaOH, and we are given the mass as 20 grams. So simply we will write here 40 grams of NaOH contains 40 grams of NaOH contains how many electrons? See, Na. There is only one Na. Na contains how many electrons? One electron in the end. Then oxygen contains two electrons, or no, we will simply count all 11 electrons, and oxygen will contain 8 electrons, and hydrogen will contain only one electron here. So which will give us 20 electrons in total in 1 mole of, or we can say 40 grams of NaOH contains 20 electrons. Then how 20 grams of NaOH will contain, if the left hand side is divided by 2, we have to divide the right hand side also by the 2, by the factor of 2, then the answer will be 10 electrons. So this is our answer, that is in 20 grams of NaOH we will be having 10 electrons. I hope you all understood. Next is the law of multiple proportions, that is for you, and 4 demerits of Bohr model, Bohr atomic model is also for you. Next, photoelectric effect is also for you. See, I will discuss only one demerit of Bohr atomic model, that is, it could not explain the uh, line spectrum of multi-electronic species except for hydrogen. Like hydrogen is only single electronic species, so it explains that. But in case of multi-electronic species, Bohr's atomic model fails. The other two, you can add that it could not explain the behavior in of the electron in the. Uh, it could not explain the Zeeman effect or the Stark's effect. Next is the photoelectric effect. Photoelectric effect is a very good effect. Yeah, it is the question number 14. Question number 14 we are going to do now. Photo effect, electric effect, like this is a piece of metal, metallic piece. Then, uh, yeah, we are producing photons. This light, radiations. We are just have a source of radiation in which the radiations are coming in the form of photons. Photons are the small packets of light which contains the energy. Okay, when these radiations strike the metal surface, the metal tends to release electrons. Okay, and at a particular frequency, at a fixed frequency, the when the photons are projected towards the metallic surface by that particular frequency, then only the electrons eject out of the metallic surface, and that frequency is called as a threshold frequency. Threshold frequency. So this is the thing that the photoelectric effect states, and we can also add that h nu equals to h nu naught plus kinetic energy given by Sir Einstein, where h nu is the total energy that you gave in the to the source from which the photons are ejected towards the metallic surface. H nu naught is the work function which is required for the electrons to start ejecting from the metallic surface, and kinetic energy is the energy then possessed by the electron, that how far this electron can move. I hope you understood the 14th question. Now we will move towards the 15th question. 15th question. What is the ratio of energies of two radiations of one of wavelength 6000 angstrom and the other with the 2000 angstrom? So simple it is. We have just done this same kind of question in the 10th question of MCQs. Even. Even will be Hc upon lambda 1, where lambda 1 is 6k angstroms. 6000 angstrom. And E2 is Hc by lambda 2, which is 2000 angstrom. Now, when we will divide E1 by E2, we will get E1 upon E2, which is equal to 3 upon 1, which is the required ratio. We were given the ratio only. Yeah. So that 3 is to 1 is the right answer for this question. It is a ratio. Okay. Now the 16th question. Write the main postulates of Bohr's atomic model. You have to write about, you can write 6 to 8 postulates, like angular by for momentum you can write, or the energy possessed by the orbit you can write. So many other postulates, like radius, about the radius you can write. Okay, now we will move towards the next question, that is the 17th question here. Let me just erase all of this stuff from here. All right. Now the 17th question. What does it say? Electrons. Okay, it is in two parts. The first part. Electrons are emitted with zero velocity from a metal surface when it is exposed to a radiation of wavelength 6800 angstrom. Calculate the threshold frequency and work function of the metal. Okay, so since they are given, we have been given in the question that the kinetic energy of the electrons is zero. How did I identify that the kinetic energy of the electrons is zero? Because they are saying electrons are emitted with zero velocity. Zero velocity means kinetic energy is zero because kinetic energy is none other than half mv square, where v is the velocity. If v is zero, this whole thing will be zero. Then therefore the kinetic energy is zero. What we know from the photoelectric effect, that is h nu equals to h nu naught plus kinetic energy. Uh, if Wait a minute, there's so much of lots of disturbances outside. Please bear with it. Okay, I will just speak with more voice now. So we were given h nu plus h nu naught plus kinetic energy, and here the kinetic energy is zero. This equation I got from the photographic effect. So I am now left only with h nu equals to h nu naught, h nu naught. Okay, so simply I will cut h and h. So nu will be equal to nu naught. Okay, nu will be equal to nu naught. That is the radiation of the wavelength that is exposed here is the work function only, or we can not the work function but the threshold energy. Therefore the threshold energy is the given threshold frequency is the given frequency, that is 6800 angstrom. 6800 angstrom will be the threshold frequency here, but to calculate the work function, that is w naught, we have to multiply it 6800. Now while finding the work function, we have to make this whole thing in uh, SI units. So it will be 10 raised to power minus 10 if I am not wrong. Then multiplying it with the Planck's constant, that is 6.673. Is it? Maybe or maybe not. Let it be 6.673 multiplied by 10 raised to power minus 34 joule second. Now h nu naught will be equal to, let me just calculate it simply, or I will leave it for you. You have to write the answer. Now the next question. Next question. We are given who has higher energy, a photon of red light with a wavelength of 7500 angstrom or a photon of green light with a wavelength of 5250 angstrom. Now, if you know that energy, oh wait, this E, what's happening? Let me just erase it, the first part. Now we will do the second part here. Then the second part here, it is, yeah, photon of red light of wavelength 7500 angstrom. That is the lambda 1 equals to 7500 angstrom, and lambda 2 is 5250 angstrom. 5250 angstrom. If you remember carefully that energy is always and always inversely proportional to the wavelength. Energy is always and always inversely proportional to the wavelength. Most of you will say that this is more and this is less. So lambda 2 will be more, or we can say the energy of the green light will be more than the red light. But that's not the case here, because angstrom here plays a very important role. See, it's just like You have written 7500, or is it? Yeah, it is like this only. Sorry. 7500 angstrom and 5250 angstrom. Simply it is greater. 7500 angstrom is a greater value and 5250 angstrom is a lesser value. 7500 angstrom and 5250 angstrom. Yeah, true, true. So simply the energy of the photon having green light will be more. Energy of green light is more. Okay. All right. Now comes the 18th question. Describe the or explain the line spectrum of hydrogen atom. In detail, you have to write Lyman, Bound, Austin, prefund bracket, Humphrey, I guess. Next question, the favorite question of every school. This question you will see in your annual examinations, in your midterms, and everywhere you will find this. A compound of mass on analysis gave the following composition: carbon 40%, H 6.67%, oxygen 53.33%. The molecular mass of the compound is 180 grams. Okay, we are given with the molecular mass, and the molecular mass of the compound is 180 grams. Okay, now we have to find the empirical formula and then the molecular formula. How can we? Firstly, we have to find the number of moles of carbon. How do we find it? Simply the percentage that is given in the question divided it by the mass of 1 mole of and 1 mole of the given element. So if we will divide it with this 20 to the 24, 12 0, 36, it will be 3.3. Then comes the hydrogen atom, that is 6.67. Mass of H, what do we take here? 2 or 3? I mean 2 or 1. We will take here 1 or 2. H, we will take here 1. So it will be 6.67. Same. Then comes the oxygen, which is 53.33 divided by mass of oxygen 16. I think we should take here 2 because H2. No, no, no. Here will be 1 only. This is 1. 1 is correct here. Now we will divide, when we will divide this, 16 threes of 48 we get and 16 fours of 64 we get. 16 threes of 48 we will write here. Point, let it be something. Doesn't matter because in the next question we have to, in the next step we have to round it off and make it in simpler whole number ratios. See, this is 3, this is 6, this is 3. Can I write this 3.3 as 3 and this 6.67? Let it be 6. Then this 3 point something something something. Let it be 3 only. Now make a simpler whole number ratio of this. This is 1. This will be 2. Simply I am dividing this all three numbers with 3. I got 3 to 1. Also, I mean 1 to 1. Now the empirical formula. I can write the empirical formula now. Empirical formula. Empirical formula will be CH2O. CH2O is the empirical formula that I got. How so? See here. For C, I got 1 as the simplest whole number ratio, and for H, I got 2, and for O, I got 1. Now CH2O. Now I can write the, wait a minute, let me just drag it a little down or a little up. Yeah. Now here we got some clear space. Empirical formula is given. What is the empirical mass? mass. Empirical mass will be 12 plus 2, 24 plus 16, 30, 40 grams. Did I calculate it correctly? This is 12. This is 2. 12 plus 2 will be 24 plus 16 will give me 40. Yes. Now, what was the molecular mass that I was having? It is 180 grams. Molecular mass. Molecular mass is 180. Did I make a mistake here? 12 plus 24. 12 plus 2. 12 plus 2 will be 14 then. This is not the correct thing that I'm doing. This will be 30 here, not 40. You guys didn't tell me that I am doing this kind of blunder. No worries at all. Now we will write here 30 corrected. Yeah, it is 30 grams. Molecular mass was 180 grams. You have to calculate the N here. N is simply molecular mass divided by the empirical formula mass, that is 180 divided by 30, which will be equal to 6. Now here comes the molecular formula, the final answer. Molecular formula. It will be simply CH2O. Here will be 6. Opening this, we will be getting C6H12, O6. And this is a very familiar compound, glucose. With this note, we have completed all the 19 questions of the sample unit test paper. I hope you understood well and found this video uh, useful for you. Okay, it was of 90 minutes, and I think we have completed it very early.